Hello, dear friends, dear students. Good morning to all of you. I am here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. Dear students, in last 3 videos, we have studied about temperature measurement, the part of the instrumentation system, measurement part of the instrumentation system. Today, we will go for the measurement of the pressure. What is the pressure and how it can be measured? What are the sensors and devices used for the pressure measurement? This is also a part of your syllabus. Hence, we will go today for the measurement of pressure. I request you kindly listen and see the video carefully and make the notes on the particular this pressure measurement. Let us see what is pressure. The pressure is the ratio of force to area F by A, over which that force is distributed. It is force per unit area applied in a direction perpendicular to the surface of the object. An action of one force against another force can be called as a pressure. The pressure is a force applied to or distributed over a surface. So, dear students, you understand this definition. Pressure is the ratio of, simply we can say, force to the area over which that force is distributed. In next slide we will see how do we measure the pressure. The measurement and control of fluid pressure is important in process industries. A pressure sensor measures pressures, typically of gases or liquids. Pressure sensor acts as a transducer. It generates a signal as a function of the pressure imposed, and the signal will be electrical. Pressure sensors can be used to indirectly measure other variables such as fluid, gas, flow, speed, water level and altitude, etc. What are the types of pressure? Because this idea you must know. Before the devices we study, we must know what are the various types of the pressure. The one of the pressure is called as the atmospheric pressure. It is the pressure that an area experiences due to the force exerted by the atmosphere. So, atmospheric pressure is the pressure that an particular area experiences due to the force exerted by the atmosphere. Then gauge pressure. Gauge pressure is the pressure relative to the atmospheric pressure. It can be described as how much above or below is the pressure with respect to the atmospheric pressure. That is measured in terms of the gauge particularly, above or below the particular atmospheric pressure. Then vacuum pressure. Vacuum pressure is the pressure below atmospheric pressure. it is measured by using vacuum gauges, which will indicate the difference between the atmospheric pressure and the absolute pressure. So what is vacuum pressure? Vacuum pressure is the pressure which is below the particular atmospheric pressure, and it is measured by using the vacuum gauges, which will indicate the difference between the atmospheric pressure and absolute pressure, right? Then absolute pressure. We have used this word in before this definition, but what is absolute pressure? Absolute pressure measured above the total vacuum are zero absolute, and zero absolute represents total lack of pressure. So absolute pressure measured above the total vacuum. Then differential pressure. It can be defined as the difference in magnitude between some pressure value and some reference pressure. So what is basically differential means it is a difference of pressure. So it can be defined as the difference in magnitude between some pressure value and some reference pressure. Absolute pressure can be considered as a differential pressure with total vacuum or zero absolute as the reference. Gauge pressure could be considered as differential pressure with atmospheric pressure as the reference. Then static and dynamic pressure. Static pressure is uniform in all directions. So pressure measurement are independent on the direction in an immovable fluid flow. If pressure is applied on the surface perpendicular to the flow direction, while having the little impact on the surface parallel to the flow direction, and this directional component which is present in moving fluid can be called as dynamic pressure. Static pressure is uniform in all directions, but dynamic pressure is the pressure in the direction of the moving of the particular fluid. So these are the types of various pressures which we have seen. Once again I will remind you: atmospheric pressure, gauge pressure, vacuum pressure, absolute pressure, differential pressure, static and dynamic pressure. Then what are the types of pressure measurement? This is the important. Number one, liquid column method uses this manometer. So let us see what are the types of pressure measurement. Liquid column method. These type of devices are those in which the pressure being measured is balanced against the pressure exerted by a column of liquid, and if the density of the liquid is known, the height of the liquid column is a measure of pressure, like the manometers. Example are the manometers. This type of devices are those in which pressure being measured is balanced against the pressure exerted by the column of liquid. One column of liquid in which the pressure is exerted, and if the density of the liquid is known, the height of the liquid column is measure of pressure. This is manometer. You can see the diagram first here. This is one example of the manometer. Here you can see this, and here you can have the liquid in this tube. This is the glass tube here. This is the glass tube here. So this glass tube is filled with the liquid, and the height of the liquid will decide how much pressure is exerted. This manometer is used for the pressure measurement as a liquid column method. So a manometer is based on liquid column method. It can be used to measure the pressure of the fluids, and this device is based on the principle of balancing the column of liquid by the same or other column of liquid. There are two types, simple and differential manometer. In simple manometers, the simple manometers are used. Our simple manometers are those which measures pressure at a point in fluid containing in the pipe or vessel, and differential manometer measures the difference of pressure between any 2 points in a fluid contained in a pipe or vessel. So properties of manometers are they have high chemical stability, low viscosity, low capillary constant, low volatility, and low vapor pressure. So these are two types of manometers. Two principles are used. One is the simple manometer and another is the differential manometer. Differential manometer uses the difference of pressure between any 2 points in a fluid contained in a pipe, and simple manometer uses the simple fluid height. This diagram I have already shown you. This is the manometer and this is the liquid here, and the reading can be observed here of this pressure. When pressure arises across this, height of this liquid can be measured. So this is the example of the manometer. Once again, I will remind about this pressure measurement. Pressure is the action of one force against another over a surface. The pressure P of a force F distributed over an area A is defined as P is equal to F by A. F is the force and A is the area. And the unit of pressure standards are Newton per square meter, that is Pascal, abbreviated as PA, kPa, kilopascal, or 1 bar is equal to 100 kilopascal. This is the unit of measurement of the pressure. What are the sensing elements? Rather than this manometer, the main types of sensing elements are like Burden tubes, diaphragms, bellows. The basic pressure of sensing element can be configured as a C-shaped Burden tube. Later on we will see in the next slide. C-shaped Burden tube, that is figure A. Then a helical Burden tube, that is figure B. Flat diaphragm, that is figure C. A convoluted diaphragm, that is figure D. And a capsule, that is figure E. And lastly a set of bellows, that is figure F. You can see here this diagram, whatever the name I have taken, figure A, C shape. This is pressure. Figure A indicates the C-shaped Burden tube. This is C-shaped Burden tube. The pressure is given here. There will be a motion of this Burden tube, C-shaped Burden tube, and this motion is measured proportional to the pressure. Then figure B is the helical Burden tube. This is the helical Burden tube. You can observe the structure of helical is there. The pressure is applied here, mechanical pressure. Then motion will be there of this helical spring type, and this motion is calibrated as a pressure. Then figure C is flat diaphragm. This is the figure C. Flat diaphragm here. Pressure is applied here. The movement of the diaphragm will be there, and this will motion, mechanical motion will be observed, and this will be calibrated in terms of pressure. Then figure D will be convoluted diaphragm. This is the figure D, is the convoluted diaphragm. Here you can see this structure. Pressure is applied here and you will get the motion, mechanical motion. The convoluted diaphragm is used here. Then figure E is the capsule. You can see this figure E. This is called as a capsule. Pressure is applied and motion of this capsule will be here. And finally, figure F is the set of bellows. This is the figure of bellows. Later on we will see one more figure of this bellow. The pressure is applied here. The movement of this rubber type bellows are there, and this will move here. This motion is calibrated into pressure. So like the rubber spring, you can say, these bellows are there. So these are the basic sensing elements for measurement of pressure. These are called as the sensors for the measurement of the pressure. What are the bellows? We have seen here, this is the C-type bellow, this is the helical bellow. Bellows sensor is an axially flexible cylindrical enclosure with folded sides. When pressure is applied through an opening, the closed end extremely axially. Bellows elements can measure absolute pressure, gauge pressure, vacuum or differential pressure. And what are the burden tubes? Burden tubes. A burden gauge uses a coiled tube which, as it expands due to pressure increase, causes a rotation of an arm connected to the tube. Burden tube are often used in harsh environments and high pressures, but can also be used for very low pressure. The response time, however, is slower than the bellows or diaphragm. C-type burden tube PSI range as low as 0 to 15 PSI, this is the unit of pressure, up to 0 to 1500. Helical burden range as low as 0 to 200 PSI, up to 0 to 6000 PSI. And spiral burden tube range as low as 0 to 10 PSI, up to 0 to 100,000 PSI. This is about burden tube and bellows. You can see here, this is the helical burden tube. This figure A is helical burden tube C-type, can be a C-shaped burden tube, and this is the helical burden tube B-type, this figure. And these are the bellows. Flat diaphragm, these two are the flat diaphragm, and this figure F is the bellows. These are the bellows. So we have seen regarding these bellows and burden tubes. These are the two important sensing elements. You can see here, bellows sensors is an axially flexible cylindrical enclosure with folded sides. When pressure is applied through an opening, the closed end extends axially. Bellows elements can measure absolute pressure, gauge pressure, vacuum or differential pressure. This is the diagram of the bellows. These are the flexible bellows. Due to applied pressure here, this bellows can be expand, and due to this expansion of bellows, this motion will be there. There may be a small rod or small type axle type is there. This will move. This is another type of bellow. Input pressure is applied. Due to this pressure, this will be expand, and due to this expansion, this meter will give the needle will move, and this will provide you the measurement of pressure. Exact diagram of bellows you can see here. This is the pressure inlet, and this is the spring resistance, this one, and this is bellow. This white portion you can see, this is bellow, and as pressure goes here, the movement of the spring is there, and this bellows will expand. Accordingly, mechanical linkage is there, and this mechanical linkage will be connected to this needle, and this needle will move. If the pressure comes out, then needle will be up. If the pressure goes in, needle will be down, and this is calibrated. So you will get the reading over this display. So these are the bellows. Burden tube. Actual diagram of burden tube you can